NASA scientists find evidence of liquid water found on Mars's surface. NASA is a highly anticipated paper published in the journal Nature Geoscience revealed strong evidence that seasonal salty water still flows on the red planet. Thanks to new technologies, the Mars Reconnaissance Orbiter, scientists confirmed that dark streaks visible in this photo released on September 28, 2015 are caused by flowing water. Liquid water runs down canyons and crater walls over the summer months on Mars, according to researchers who say the discovery raises the chances of being home to some form of life. The trickles leave long dark stains on the Martian terrain that can reach hundreds of meters downhill in the warmer months before they dry up in the autumn as surface temperatures drop. Images taken from the Mars orbiter show cliffs and the steep walls of valleys and craters streaked with summertime flows that in the most active spots combine to form intricate fan-like patterns. Scientists are unsure where the water comes from, but it may rise up from underground icy or salty aquifers, or condense out of the thin Martian atmosphere. There is liquid water today on the surface of Mars. Michael Mayer, the lead scientist of NASA's Mars exploration program, told The Guardian, "Because of this, we suspect that it is at least possible to have a habitable environment today. The water flows could point NASA and other space agencies toward the most promising sites to find life on Mars, and to landing spots for future human missions, where water can be collected from a natural supply. Mars is not the dry, arid planet that we thought of it in the past," said NASA's Jim Green. "Liquid water has been found on Mars." Some of the earliest missions on Mars revealed a planet with a watery past. Pictures beamed back to Earth in the 1970s showed a surface crossed by dried-up rivers and plains once submerged beneath vast ancient lakes. Earlier this year, NASA unveiled evidence of an ocean that might have covered half of the planet's northern hemisphere in the distant past. Well, look at that. You see the streaks are just damn near long, I gotta say. Researchers have now turned to another instrument on board the Mars Reconnaissance Orbiter to analyze the chemistry of the mysterious RSL flows. Of Georgia Institute of Technology in Atlanta and his colleagues used a spectrometer on the MRO to look at infrared light reflected off steep rocky walls when the dark streaks had just begun to appear and when they had grown to full length at the end of the Martian summer. Writing in the journal Nature Geosciences, the team describes how it found infrared signatures for hydrated salts when the dark flows were present, but none before they had grown. The hydrated salts, a mix of chlorates and perchlorates, are a smoking gun for the presence of water at all four sites inspected: the Hale Paliker and Harowitz craters, and a large canyon called Coprates Chasm. These may be the best places to search for extant life near the surface of Mars, said Alfred McEwen, a planetary geologist at the University of Arizona and senior author on the study. While it would be very important to find evidence of ancient life, it would be very difficult to understand the biology. Current life would be much more informative. The flows only appear when the surface of Mars rises above -23°C. The water can run in such frigid conditions because the salts lower the freezing point of water, keeping it liquid far below 0°C. The mystery has been what is permitting this flow. Presumably water, but until now there has been no spectral signature. Mayer said, "From this we conclude that the RSL are generated by water intricating with percolates, forming a brine that flows downhill." Very interesting. For now, researchers are focused on learning where the water comes from. Porous rocks under the Martian surface might hold frozen water that melts in the summer months and seeps up to the surface. Another possibility is that highly concentrated saline aquifers are dotted around beneath the surface, not as pools of water, but as saturated volumes of gritty rock. These could cause flows in some areas, but cannot easily explain water seeping down from the top of crater walls. A third possibility, and one favored by McEwen, is that salts on the Martian surface absorb water from the atmosphere until they have enough to run downhill. The process, known as deliquescence, is seen in the Atacama Desert, where the resulting damp patches are the only known place for microbes to live. It's a fascinating piece of work, Burgess said. Our view of Mars is changing, and we'll be discussing this for a long time to come. Thanks for watching my video, guys. Make sure you guys subscribe and share the video, and keep on watching.